So the next component of the hoisting system is the block and tackle, and block and tackle main function is to provide mechanical advantage, which permits easier handling of large loads. So it has a couple of main components, which includes the crown block, which is this crown block on the top of this picture. You can see the traveling block, and the traveling block is this one, which is traveling up and down, and the drilling line. So now these are the main components of the block and tackle, and as I mentioned, the main purpose of this block and tackle is to provide the mechanical advantage. You can handle the large loads easier, and you can watch a video here. The link is here. You can go ahead and watch it and see how exactly this system works. But now we want to talk about the mechanical advantage. So if you want to define the mechanical advantage is defined as the weight that the traveling block is handling divided by the force which is acted on or imposed on the drawworks. So let me go back to that figure there, and maybe we can see it better. So mechanical advantage again is the weight that is being handled by these lines. Everything is attached to this drilling hook. So your drilling stand, drill pipe system, the drill bit system, everything is attached to this drilling hook. So the weight is supported by this traveling block here, and that's the weight that we are talking about. So there is a weight force going downward, and then there is a fast line here which is connected to this drawwork. So this fast line basically supports is the force that you are inputting to the system to try to raise or lower that load. So the force which is acted on the fast line is the input force, and the weight is the resultant of that force, the work that is being done by that force. So W, which is the weight that we are handling, divided by the force that we are inputting, that's called mechanical advantage. So now the ideal mechanical advantage, if you wish, is called a mechanical advantage that assumes no friction in the block and tackle system, and that is the initially we do calculation with that. But before that, I guess I'm gonna define some simple physics that you already should know, I guess, and look at this very simple system. There is a pulley system, right? And there is a weight attached, there is a line, and there is a tension in this line which is attached to this drawwork, right? So it's a very simple system. It's a pulley, there is a weight acting downward, and there is a tension again acting downward as well, right? So if you want to write the force balance for this system, simply T is equal to W, right? That's the force balance on this system. Now, how much force are you putting on the derrick for this system? So derrick is this, again, four-legged structure, right? How much force are you putting on this point? There are two forces acting on that point, right? W and T. So the total force which acting on the derrick, or derrick load as we call it, is T plus W, which is act on the top here, right? So sometime we will show it with FD later on as well, but here let's just say LD, right? That's the force which is acting on the derrick, and that's the summation of T plus W. And since T and W are equal, so it's 2 multiplied by W, right? And then here we of course assume there is no friction in the sheaves here. Now, how does the mechanical advantage really work? So if you have 100 pounds, you have a pulley system, you apply 100 pounds, you raise this weight, right? This is number one. Now, what if you have 100 pounds, right? So here, what is your mechanical advantage? Is W over the force that you are putting. So W is 100 pounds. The force that you are imposing on this line is also 100 pounds, which means that's equal to 1, right? So mechanical advantage equal to 1 here. And when mechanical advantage is equal to 1, it means that there is no advantage actually. So mechanical advantage larger than 1 represent an advantage. And here there is 100 pounds, you're applying 100 pounds. It's just the same force you're acting, right? Now look at this system. There is 100 pounds here. So there is a weight which is equal to 100 pounds applied here. And then there are two tensions in the line, right? So one here and two. So this 100 pounds is handled by two tensions, right? So these two tensions will handle this. So W, if I call these two T, and if there is no friction, of course, W is equal to 2T, right? So each of these tensions in the lines will be 50 pounds. Right, so if this is 100 pounds, each of these lines will handle 50 pounds. And then if you consider the force body diagram for this pulley here, there is one here, there is one here, so these two should be equal to each other. This is 50, this is 50, so you're applying 50 actually to raise a 100-pound weight, right? So the mechanical advantage for this system is again 100 divided by 50 this time, because that's the force you're applying, so it's 2. Right, so this system is helping you. Now look at the last one. So there is 1, 2, 3, 4 that are acting on this weight W, which is 100 pounds. So W in this case is equal to 40, right? And therefore, since W is 100 pounds, T is 25 pounds. And if you look at this system, this pulley here, if this is 25, then this is also 25. So there is a 25 pounds tension that you need to apply. So here the mechanical advantage is 100 divided by 25, and that's 4, right? So that's exactly how our block and tackle system works. So we have number of lines here. So one thing that I needed to mention here is, you see, as the number of lines increases, the mechanical advantage increases. And if you noticed, your mechanical advantage is equal to the number of the lines that are attached to that weight. In this case it's 2, in this case it's 4. Your mechanical advantage is 4 as well, right? So mechanical advantage for ideal systems is equal to the number of lines that are attached. And this is a simple force balance. This example showed you how this system works. So that is true also when you have what we have inside the block and tackle system. So there is a fast line. That's the line that you're imposing the force on, and there are many of those lines strong to the weight that is moving downward. The weight again is the drill string weight, right? The drill weight, whatever is downhole basically, right? So you're trying to give a mechanical advantage by increasing the number of lines here, and then this force will be lower, right? So based on what we discussed, the mechanical advantage here is W over FF, and if it's an ideal system, this is equal to the number of lines which are here. So these number of lines is the mechanical advantage here. So so that's for an ideal system, right? So the mechanical advantage is this, right? So you can write it another way. W is FF is W over number of lines. That's how it's basically developed, right? So that's the mechanical advantage for block and tackle system. Now the efficiencies, this is, as I mentioned, this is ideal mechanical efficiency, right? So you should notice that the efficiency is not 100%. If you go to table 1.2 of the book, 1.2 of the book, you see a table which says number of lines and then efficiency, E. So 6, 8, 10, so on and so forth, and then 0.87, 0.84, and so on and so forth. So it gives you the efficiency depending on the number of lines that you have. So that reduces your mechanical efficiency of the system. Okay. Well, in the next video, we'll continue this topic and we'll calculate also the force on the derrick in the a real system that you can see here.